Welcome students in our third lecture of complex analysis. In this lecture, we'll discuss on harmonic function, how to construct an analytic function in two ways. First, one way is Milne's method. So let's see at first what is a harmonic function. Any function that satisfies the Laplace equation is known as harmonic function actually. So any function fxy fxy is said to be harmonic if it satisfies, it means the function satisfies the Laplace equation. That is del 2f del x square plus del 2f del y square is equal to 0. If any function satisfies this equation, its Laplace equation, then the function is called harmonic function. That means if we two times partially differentiate any function f with respect to x, two times partially differentiate f with respect to x, and two times partially differentiate f with respect to y, and add them, and if the sum is equal 0, then the function is known as harmonic function. Construction of analytic function. It's very important part of complex analysis. Let you are given a complex variable function fz equal u plus ib, and in your exam question paper you are given u and you have to find v. In your exam question paper you are given u and you have to find v. It's the construction of analytic function. Why? As until you find u and v both, I repeat students, until you find u and v both, you can't construct fz, and fz is as you can't construct fz, that means you can't construct analytic function. So these kind of questions actually come into two ways. When one is when u is given and we need to find v, and when v is given we need to find u. One, when u is given. Two, when v is given. And look students, by these two, the fz that we will get, by these two, the fz that we will get, this fz will be in terms of x and y. In terms of x and y. Without these two methods, we have another method to construct on an analytic function and its Milne's method. And this Milne's method has also two conditions. One is when u is given, and the second condition is when v is given. Milne's method has also two conditions, when u is given and when v is given. But the fz that we will get from here will be in terms of z. Fz in terms of z. By the previous two methods, the fz will come in terms of x and y. By Milne's method, the fz will come in terms of z. That means by Milne's method, we don't need to form fz in terms of z by making with x and y. It will come automatically in terms of z. That's why the answer will come first than this with Milne's method. So by this method, the answer will come first. As Milne's method gives our answer first, so we will concentrate on Milne's method most. So now the question is how we will apply this Milne's method. That's why we should keep our mind some working rules. First rule, when u is given, that is real part of fz is given, then our first step 1, write u and find del u, del x, del u, del y. Second step, put x equal z and y equal 0 into del u, del x and del u, del y. Third step, evaluate fz equal to integration del u, del x at z equal 0, z 0 minus I So when u is given, our first step will be, we'll write u and find del u, del u, del x and del u, del y. Then we'll put x equal z and y equal 0 in this. Then we will integrate this del u del x z0 dz minus I del u del y z0 dz plus c. Here c is an arbitrary constant. So I repeat, students, at first we will write u and find del u del x and del u del y, and we will put x equal z and y equal 0 in these two. Then we will integrate this, and after integrating we will get fz. Here u is given. In similar way, when b will be given, then we will find also fz. So let's see how we will find fz when b is given. Now step 1, when b is given, then write b and find del b del x and del b del y, and substitute x equal z and y equal 0 into these two, del b del x and del b del y. Now evaluate. Fz equal integration del b del y z0 dz plus I del b del x z0 dz plus c. C is a arbitrary constant. So by these two conditions of Milne's method, we will find any fz easily when b is given, when u is given. Okay, now let's see a question. Then you will easily can be able to find any fz in your exam question paper. Here this question is, if u equal this, then find z. So our first step is u equal x cube minus 3xy square plus 3x square minus 3y square. Then we have to find del u del x and del u del y. So del u del x will be 3x square minus 3y square plus 6x. Okay, then del u del y is equal to minus 6xy and minus 6y. Now put x equal z and y equal 0 in del u del x and del u del y. That means del u del x z0 will be, this will be 0, this will be 0 as y equals 0 and x equal z. That's why it will be 3x square plus 6x. And del u del y z0 will be y equals 0. That means this will be 0 and this will be 0. The remaining part will be 0. Okay, now I have to evaluate by Milne's method. By Milne's method, fz equal this. The value of this equal to 3x square plus 6x. 3x square plus 6x dx plus I. The value of this equal 0. 0, sorry, plus c. If we integrate this, it will be sorry, z. Here x is z. It will be 3z square plus 6z. So it will be 3z cubed by 3 plus 6z square by 2 plus this will be 0, this will be minus 0 plus c. Therefore we can find fz is equal to z cube plus 3z square plus c, and it's our required answer. It's all about today's video. There's an announcement, students. We have launched a game developing company, JAIPAL, and we have made a mind-blowing game that you will like, I hope, and we will be able to give you within the next 5 or 6 months. So subscribe our channel for further information. Thank you.